Okay. So, if you look, you notice on this page, see on the right side, it has the little calculator, but it has a line through it. Okay, so that probably means you cannot use a, what? Calculator. However, after number 9, you can use a calculator, which is when you might need it. Okay? So, let's look at the sample question on the left. All right, so we have x squared plus 2x minus 24 over 3x plus 18. Okay. It's not up there. All right. There is a few different ways we can solve this. Okay. So, you don't have to write this part down, but I'm just going to note it so we've got it. So, ways to solve. There are 2 types of division that I can do. What's one of them? Long division or starts with an S. Not simple, but synthetic. All right, so these 2 options are the harder options. I want to think of something simpler. What can I do with the numerator and the denominator? I can do the big X on which one? I can do the big X on the top, and then can I do the big X on the bottom? No, but can I still factor it? Yes. So we can also factor, and then at the end, when we get done factoring, we can do what? Okay, we can simplify, but if there's one on the top and one on the bottom, we can cross out. Okay? So out of those 3 options, which ones are we most, I guess, confident in doing? Factoring and then crossing out, right? So, let's factor the numerator. The easiest option here is what? The big X. We could also do the, not the box, but not the rainbow. Quadratic formula. Right? Or we could graph it. But it's a non-calculator, so we obviously can't graph it. So let's do the big X. What's going in the bottom of that X? 2. And in the top? Yep. All right. What adds to negative 24? Multiplies to negative 24 and adds to 2. Not negative 6 and 4, but 6 and negative 4. Yeah. Okay. So, if I had something besides 1 in the A value, what would I need to do to 6 and negative 4? So, like right now in the top, my A value is 1. If that A value wasn't 1, I have to divide it by that A value, right? But if it's 1, if I divide by 1, does it change that? No. So we have 2 polynomials of x plus 6 and x minus 4. All right, if we factor the denominator, what kind of function is that? It's linear. So I can't factor out an x because the 18 doesn't have an x. But I can factor out a number. What number goes into both 3 and 18? 3. So let's factor out a 3. I've tried to get to a 3x, but I just have a 3, so I need a x. trying to get to 18, but I have a 3, so I need a 6, right? Now, everything's factored. Can't go any further. So you look, is there something on the top and the bottom? X plus 6. So what can I do with those? I can cross them out. And I'm left x minus 4 over 3. So, on your paper, what is that? It's A. Good. All right, number 1 on the right. Simplify the expression. So, we have 2 minus 3i, 4 plus 2i. So, for right this second, let's treat that I as if it was an X. Okay? So, what method are we going to do? The box, right? So, got our box. 2 minus 3i and 4 plus 2i. All right, 4 times 2 is 8. 4 times negative 3i is negative 12i. 2i times 2 is 4i. And 2i times negative 3i is negative 6i squared. All right, now, what is this I that we're using? What is it standing for? Wait, okay, hold on. What is I? The letter I. What word does that stand for? Imaginary, okay? So, now, y'all are right. Y'all are the only class that's done this, so good. I squared equals, what'd y'all just say? Just negative 1, right. I would be the square root of negative 1, but I squared is negative 1, okay? So if we write this out, we've got 8 minus 12i plus 4i minus 6i squared. Okay? Anytime you see I squared, what do you have to plug in? Not a 1, but a negative 1, because I squared equals negative 1. So we've got 8. If I combine negative 12i and positive 4i, I get a, what? Negative 12 plus 4? A negative 8i. And negative 6 times negative 1. That becomes a positive 6, yes. So 8 minus 8i plus 6. And now I can go one more time. What 2 things do I combine? 8 and 6, and I get 14 minus 8i. Now, one thing to note here is when you are doing complex numbers, it must be written. A can be a positive or negative number. B can be a positive or negative number, but which one has the I attached?
What are you talking about? I'm confused.
If we're just writing the general form of a complex number. Just looking at this answer choice. If A comes first and B comes second, which one is the I attached to? It's attached to B. So we know the I goes in the back because back starts with B, right? So 2 things you need to know here. This and this. So make sure you have those 2 things down and you have them boxed or circled or whatever. Number 2 says Fanny is making a rectangular blanket The length of the blanket is 10 inches greater than its width, W, in inches. So, we're making a rectangular basket. So, I want you to underline. The length of the blanket is 10 inches greater than its width, W. Then, I want you to write, W equals L equals. So if I read that one more time, the length of the blanket is 10 inches greater than its width, W. What is the width? W. Okay, they're not giving us a number. They're not giving us a value. They're just saying the width is W. Okay? So now let's go back to the length. It says the length of the blanket is 10 inches greater than its width. So if it's 10 inches greater than its width, what is the length going to look like? Do we know the width? No, we just know it's what? We just know it's W. So we have W. If it's greater than, is that going to be a positive 10 or a negative 10? Positive. And then we know it's 10. So my length is W plus 10. My width is W. Okay? Then it says, write the function f of W that describes the area. Well, what does the area equal? What times what? Length times width. Is that the same thing as width times length? Yes. Okay. So when we write that formula, our length is W plus 10. And then we're multiplying it by a additional W. So it's going to look like this. W times W plus 10. Both of these are the same. However, which one is more familiar, the top or the bottom? The bottom one, right? What is the remainder? Circle remainder. How do we do it? We can do long division or synthetic, absolutely. So, we're going to do it both ways, okay? So, let's do synthetic first. So, what does synthetic use? All right, an upside down division sign, which looks like, I guess, kind of what letter? An L. So go ahead and draw me an L. All right, now what do you do with all your values or all your coefficients for synthetic? Right, we put them in our box. So we've got what's in front of the x cubed. So we have 1, and then it is a 3, and then it's a negative 10, and then it's a negative 14. Now, what does the word synthetic start with? An S. And what does the word solution start with? S. So remember, when you do synthetic, you have to find your solution. So we're dividing by x minus 3. That's what it tells me. How do I find the solution from there? How do I find the solution from x minus 3? First, I set it equal to 0 and then solve. So you get what, Addie? X plus, well, not x plus 3, but x equals? X equals 3. All right, and where does that 3 go? On the side. All right, first step, you bring down what term? the first term, which is the 1. So you bring it straight down. You got a 1 down there. Then I say what, or 1 times 3, which is 3. If the number we get when we multiply is positive, I add them, right? So 3 plus 3 is 6. 6 times 3 is 18. Negative 10 plus 18 is 8. 8 times 3 is 24. Negative 14 plus 24 is positive 10. Now you can look at this 2 ways. You can look and see that your last number is always your remainder. So the last number is a 10, so the remainder is 10. Or you can write out the quotient. When you do the quotient, is the power 1 more or 1 less? 1 less, right? So we started with an x cubed. So we're going to end with an x squared plus 6x plus 8 plus 10 over x minus 3. All right, so long division is called long division because it gets pretty what? It gets pretty long, right? So we have x minus 3. All right, now where do we start? Inside divided by outside, right? So we have x cubed divided by x, which is an x squared. And then we multiply. So x squared times x is x cubed. And x squared times negative 3 is negative 3x squared. Now, when we subtract, what has to go around that? Parentheses. The first 2 cancel. And then you have 3 minus a negative 3. Those 2 negatives on the bottom make a positive. So 3 plus 3 is 6. And you bring down your negative 10x. And then you start all over again.
So you multiply,
Divide, multiply, subtract. Yeah. All right, so y'all finish this one out. All right, let's do it one more time and then you finish it. Okay. All right, so you take the first term. What's the first term you're starting with now? 6x squared, right? So 6x squared divided by what's on the outside, which is just x, and you get 6x. And then you multiply. A 6x times an x is a, yep. And a 6x times a negative 3 is a negative.
Wait. A 6x times a negative 3?
Uh-huh.
Is negative 18.
Yep. Negative 18x. Subtract, but what has to go around that stuff? Parentheses. And then the first 2 always what? Cancel. That would turn to a positive. So you have negative 10 plus 18, which is 8x, and you bring down your negative 14. All right, you finish it out. Oh no. So here, you should have said 8x divided by, bless you, x, and you should get what here? 8, right? So your 8 goes up here. All right, then 8 times x is 8x. And then 8 times the negative 3 is negative 24. All right. Subtract, but if you don't put them in parentheses, it ain't going to work. So 8 minus 8, you cross out. And then that 24 becomes what? Positive. So negative 14 plus 24 leaves you with 10. So you have plus 10 over x minus 3 as your remainder. Now, it would take two answers. It would either take just 10 or 10 over x minus 3 would also be correct. Okay? Either one. Got it? All right, number 4 and number 5 are a little challenging. Okay? So, bear with me. 4x plus 6y squared. Okay? It wants to know something that is equivalent. What's the word equivalent mean? Equal, right? So, I cannot, listen to me, cannot say 4x squared plus 6y squared. I cannot do that. Cannot. What you can do is what Jacqueline just said, and that was what? Write it twice. 4x plus 6y, 4x plus 6y. Now, if you look at your answer choices, do any of them look like that? No. So you have to go one step further. Okay? Let's do the box method. Yes.
Technically, would you have to? Can you not just do like square every single one of them? Like do 4 squared is 16, and then x squared is x squared, and then 6 squared is 36. Y squared.
I've had that same question maybe 12 times today. And it's all the same people whose brain thinks like my brain.
See, that's what I like.
Okay. So, 4x plus 6y. 4x, 6y. Okay? So, we simplify. 4x times 4x is 16x squared. A 6y and a 4x is 24xy. Same thing in the bottom, 24xy. 6y is 36y squared. All right, now, looking at your answer choices again. M is not correct because it does not include xy. Okay, so let's go ahead and mark out M. Now, why is P not correct?
P. Oh, P. Never mind.
The second one. I don't know why it's in P, but it should be, it needs to be A, B, C, D, but it's in M, P, or S. So why is P not correct? They tried to just put a 2 in front of it.
It is.
It is. So, right here, P is not right because parentheses.
That's so stupid.
I don't get it. Oh, I see it.
So look, here's how we talked about it earlier. How many 4x's do you see right here? 2. So I got a 4x and a 4x, which is the same thing as 4x squared.
Oh, okay.
All right? I got a 6y and a 6y. How many 6y's do I have? No.
You have 2.
I have 2. So I've got a 6y and a 6y, which is the same thing as 6y squared. How in the world did I get this and this? I multiplied what 2 things though? Okay, so now I've said 4x and 6y. And how many times did I do that? I did that twice. So how many of those pairs do I have?
2. Oh, okay.
So the only choice that I have that includes all 3 of those things is which one? Is R. What is different between R and P? Or R and S, I mean.
It don't got a 2.
It don't have a 2. And it has a 2 because I multiplied 4x and 6y twice. Okay? So that one is R. All right, now before we do number 5, I want you to write 4 equations down. Okay? At the top of the page. Not this one, I wrote it the wrong one. Sorry. A squared minus B squared. All right, so there's the first one you're writing. Second one is A cubed plus B cubed. Would this A cubed plus B cubed, would that be the sum of cubes or difference of cubes? Sum or difference? What are we doing? Sum, because we're doing what? We're adding, right? So that would be A plus B, A squared minus AB plus B squared. And then the last one is going to be the difference of cubes. Okay, I'm going to erase them. All right, so what do you notice about number 5? We have an exponent of what?
6.
Of 6, okay. Tell me this. Is this right here the same thing as?
I already answered that.
No. Oh. Wait.
In my book,
Yeah.
yes.
In my, yeah.
In my book it is 2 because 3 times 2 is 6.
Sprinkles.
Okay. Now, out of those formulas that you just wrote down, okay?
Mm-hmm.
The first one is a sum of squares,
It's not.
or difference of squares. Sorry, difference of squares. And then the other one was a sum of cubes and difference of cubes. What is the most outer exponent we're dealing with right here?
Square.
A square.
Oh.
So, that formula was a squared minus b squared equals a plus b and a minus b, right? So, this is kind of like what we did yesterday almost, where we're just kind of swapping forms. So, in this instance, what is the a value? X what? X cubed, okay? And what's the b value?
Is it square?
Y cubed. All right, so we're going to write that now in this form.
X cubed minus. What?
So I renamed x cubed and y cubed as a and b. And then I put it in a plus b, a minus b. So I split them up. Now we're down to this right here.
So,
Does that not look like your a cubed plus b cubed and your a cubed minus b cubed?
Where does the square come from?
it does.
Huh? We've already used the square.
Where?
Right here.
Oh, Jesus, Cajun. She probably didn't write it down. It's okay.
I did write it down, but I'm confused.
We got rid of the square. The square's gone.
So you just gonna always get rid of that?
You're going backwards.
You got your sum of cubes and difference of cubes on your paper? Okay. So the first one. The first set of parentheses. Is that the sum or the difference?
Oh, my bad.
The sum. Okay, so what does your sum of cubes say?
60.
The formula on your paper. You have a cubed plus b cubed equals. What's in the first parentheses?
A plus
A plus B.
Okay, so in this case it's going to be
Y.
x plus y.
X squared.
X squared?
X Y plus Y squared.
What? But they're in them. Yes.
That's the first one.
Oh, right.
So it's C.
Hmm?
Is it C?
It is C.
Oh, my goodness.
This is over.
Here's the first one.
I gotta go to work.
Now the second one. Are my letters going to change or just the signs?
Just the sign.
Just the signs. So now this one's going to say x minus y x squared. What's the formula? Plus or minus next?
Plus
Plus.
X Y minus Y.
Should be plus.
What? It's already a plus. I thought it was backwards. I thought we were flipping or something.
Sorry. It is C. That one's hard. We'll go over that. I have a couple more like that we're going to do.
And the packet might.
Not in this packet, but my other packet.
Can we do this like say that you make a video of it?
I'm making a video right now about it.
What's that?
Is my voice going to be in there?
Your voice is going to be in there.
I heard something nasty.
Okay. All right, number 6. When you see a equal sign in the middle of two fractions, what kind of multiplication do you do?
Miss Ellery, are you recording us? Oh, okay.
Why we say right?
All right, so we have 3 over x plus 3 equals 9 over x squared minus 9. Okay? When you see an equal sign in between, you always do what? Cross multiply. So I want you to write cross multiply somewhere around number 6. All right, but before you cross multiply, is there anything that I can factor?
Yes.
What can I factor?
No. Oh, X squared minus 9.
X squared minus 9, right? So let's do this. When I factor x squared minus 9, I have to use the big X. What goes in the bottom of that X?
0. Yeah.
Yeah, because B's missing. And then up top, it's going to be negative 9.
3
And
minus 3.
all right. So now, really, do we have to cross multiply? If I can get my what the same, then I can solve the top.
The bottom.
If I get my denominator the same, then I can solve the top. So look at your denominators. Are they the same?
No. But you can put x minus 3 over there to make it the same.
Okay,
Multiply.
what do you multiply it, right? On the top and bottom or just the bottom?
Just the top and bottom.
Top and the bottom. So let's say x minus 3 on the top and x minus 3 on the bottom. Now, once your denominators are the same, do you have to mess with them anymore?
No.
No, we just have to mess with the top, okay? So the top is x minus 3 times 3 equals 9. So, x times 3 is
3x.
negative 3 times positive 3 is equals 9. Alright, I got a two-step equation. What do I add over? Add the 9 over. 9 plus 9 is 3x equals 18. What do I do? Divide by 3, and x equals 6. But what do I have to do?
Put it
back in.
Put it back in. So, we put it back in. We have 3 over 6 plus 3 equals 9 over 6 squared minus 9.
Wait.
I just plugged in 6 for the x's. All right, when you simplify the left side, you get 3 over 9. When you simplify the right side, you get 9 over 36 minus 9, which is 27. All right, now those two things right there in this moment do not equal. But they both equal what?
3.
Not 3, but 1 over 3. So does 6 work?
Yeah.
Yes, the 6 does work.
So what's the answer? 1 over 3?
No, the answer is 6.
Oh.
1 over 3 shows you that 6 works.
So if it wasn't a solution, we just put in the box.
No solution. Correct. Yes. Yes. Now, you don't have to write this part, but just listen. So we could cross multiply. Okay? But let me show you what happens when you cross multiply. You get that big thing at the bottom.
What big thing?
3x squared minus 9x minus 54. Okay? So we did this morning. We did it this way. And we got to the quadratic formula, and keep in mind, this is a non-calculator. Had this not been a calculator problem, or had this been a calculator problem, I would have thought nothing about this. But we got to the end of this problem, and we're taking the square root in the quadratic formula. And you know what the square root was? 729. How many of you know the square root of 729 off the top of your head? Let's hear it.
I'm just playing. You know I did.
All right. So, way too big to do without a calculator. Okay?
So we're the only people that knew how to do this. Why are you looking at me like that?
So here, if you chose to cross multiply, is there a number that goes into 3, 9, and 54?
Is it no? Is it no?
It would have to be 3, right? So when you factor out a 3, you end up getting x squared plus, or not plus, minus 3x minus 18. So is that right there pretty normal? Factorable? What's your a value? What's in front of your x squared? 1. So you can do the big X on that, right? All right. Let's move to number 7. Number 7 is what we've been doing. Okay. So, it says Jamie deposited $627 into a savings account. The account has an interest rate of 3.5% compounded quarterly. So, it says it's compounded quarterly. So, do we use that long compound interest or the PERT?
The long one.
The long one. We only use PERT if it says it is compounded,
E.
not E, but continuously. Go, Alyssa. So, A equals,
627.
hold on, P times 1 plus R over N, close parentheses, and what's in the exponent? N times 2. Good. All right. What am I putting into my account?
627.
627. All right. What's my rate?
0.3.
All right. It's 3.5%, but you got to move it 2 times to the left.
Yes, correct.
So boom, boom. 0.035. Now N. How many quarters are in a year?
4.
4. So N is going to be 4. And T, remember, is the years. But if you notice, it says write the function that gives the amount of money in dollars in Jamie's account T years after the initial deposit. Does it give us the year? So it's just
T.
T.
They do this. They just make it.
So right here, are we solving or are we just writing? We're just writing. So A equals, or I guess it would be J of T, because that's what it tells us. 627. 1 plus 0.035 over 4. Close your parentheses, and what's going up top?
4 and T.
4 times T. Yep. All right, number 8. We're finding the equivalence. And you see it says when A is greater than 0 and X is greater than 0, mark that last part out because they put that there to try to make you think it's something hard.
Yep.
So go ahead and mark it out.
Do they want us to fail?
All right, so we have the square root of 16a to the 4th, x to the 6th. So, I'm going to split this up by saying the square root of 16 times the square root of a to the 4th times the square root of x to the 6th. That is equivalent, right? All I did was break it down. Now, one thing towards the bottom I want you to write, and then I want you to put a box around it. Now, if you have a root and there's no number on that root, what kind of root are you taking? A square root. A square root, right? So, the first one is easy. What's the square root of 16? 4. Now, I want to change this to have an exponent using what I have boxed. So I've got a to the what over what?
4 over 1.
Not 4 over 1, but 4 over 2 because we're taking the square root. Times x to the what over what?
6 over 2.
All right, now does that look like an answer choice on your paper?
Nope.
Nope, so you have to keep going. So 4, what is 4 divided by 2?
2.
And what is 6 divided by 2?
3.
So my answer is
I like this.
M.
So why did you do all that?
Why?
Yes,
Because I went,
The square root of 16
yes,
is 4.
yes, you
So
can.
why not do it?
You can. You can do that. You have to go this route because not everybody is gifted like that.
So why did the other one work like that?
What other one?
The number, this one.
Number 5?
4.
Number 4?
Yep.
Well, I don't have a square root, first of all.
Oh.
See? There's a part where you're not gifted at.
Okay.
Just kidding. Okay. All right, so number 9, I want you to put a question mark by number 9 because before I go into pH and hydroniums, I want to make sure that's on the a thing before I teach that.
Is it hard?
Is it hard? No, it's not hard, but I don't want to waste time on something that's not on there. All right, number 10. Number 10 comes from topic 1, so the very first thing we learned. Okay? So, it says the fourth term of the sequence is 108. Each term after the first term is 3 times the previous term. Write an explicit function. So I want you to underline fourth term. I want you to underline 108. I want you to underline first is 3 times the previous term.
So would you do 108 divided by 3? I don't remember this.
All right. So we're writing a function rule. Okay. F of n, because that's what it says. Write an explicit function that models the general term of the sequence f of n. Now, it's going to be a geometric sequence or an arithmetic. Okay. Because it says first is 3 times. It doesn't say 3 is added every time. It says 3 times. Is that going to be an arithmetic, which means you add, or a geometric, which means you multiply? It's going to be a geometric because it says the word times. Okay? All right, so what term am I dealing with first? What is the first thing it tells me? The fourth term, right? So we're putting a 4 first because that's what it says. That's all I know is it's the fourth term. It tells us that answer is 81. Okay? So we're not doing nothing with 81 yet. That's telling us not 81, I'm sorry, 108. It's telling us the final answer is 108. Then it says each term after the first is 3 times. So what number am I going to be multiplying by? Got to be multiplied by a 3. First is 3 times the previous term. When it says previous term, you have to know the term that comes before it. So what's going to go in that exponent? It's the recursive. N minus 1. Good. Now, I want to verify. What does verify mean? Huh? I want to verify. I'm going to plug it back in. Okay? So, here's what I want you to do. On your calculator, go to your y equals. Whatever's in there, clear it out. And I want you to hit 4 times 3. Raise it to the exponent of x minus 1. So it looks like this. 4 times 3x minus 1. And then I want you to hit second graph to pull up the table. You got a table? All right, when your x is 1, what is it right to the right of it? What does it say the y is? 4. X minus 1. When your x is 2, what does it say?
12.
Y is 12. When your x is 3, what is your y?
36.
When your x is 4, what does it say? Now, you've heard 108 when I read this, so we have to verify and make sure this is right. It says the fourth term of the sequence is 108. So that means when you put in a 4, you get out a 108. Is that true by your table? Yes. So is this the correct answer? Yes, it is.
So it's 4.
So
Huh?
it's what we wrote.
Or we put F of N. What I'm saying.
It's the 4 times 3 n minus 1. But that we're saying that is the right formula because when you put in a 4, you get out 81. Yeah. Okay. Number 11 is going to be the last one we do because it's going to take the whole time from us. So, here's what I want you to do. Left side, that blank part on your paper, I want you to write this right here. Remember the word discriminant?
Yes. No. But I don't know what that means. Wait, is it look at me because I don't remember.
All right, the discriminant is b squared minus 4ac. Where do you know b squared minus 4ac is at in the quadratic formula? Under the square root. Okay, good. So the discriminant tells us how many and what type of solutions. Okay? It's greater than 0. What kind of number is it? If a number's greater than 0, it's what?
Oh,
Positive or negative? Positive. So that means we have 2
real solution.
real solutions, yes. If the discriminant equals 0, how many real ones do we have? 1. If it is less than 0, how many?
No.
2. 2 non-real, yep.
You was halfway there, Bo. You smart too.
2 non-real. So, by looking at number 11, which one is probably not the best option to solve it by? Huh?
Less.
Huh?
Less than 0.
It is going to be less than. But is the quadratic formula the better option, or is the big X the better option? The quadratic formula, the big X is not, because that A value is what? 3. Okay? So look here. Keep this in mind. Okay? Because I'm going to erase it because I need some room. Three x squared plus 4x plus 8 equals 0. What's A value? What's B? C. All right. We're taking that and plugging it into the discriminant. Okay? Four squared minus 4 times 3 times 8. Put that in your calculator. What do you get? Huh? Negative 80? All right, is that number greater than 0, less than 0, or equal to 0? Less than. So what kind of solutions are you going to have? 2 non-real. And if they are non-real, what do they have in there? It's a little, cute little, it's on your face. No, not the eyebrow. Cute little eye. Because that I stands for imaginary. And can you see things that are non-real? No, because they're imaginary. Remember the friend, Carl? What's his name, Carl? I think his name is Carl. Okay? So, here's what we're going to do. We're not going to have time to finish solving it because it's going to take a while. So, what I want you to do, and we'll pick up tomorrow. 3x squared plus 4x plus 8 equals 0. I want you to take A, B, and C and just put it into the quadratic formula. Don't solve it. Don't do anything. Just put it into the quadratic formula. Do we remember the quadratic formula?
Mm-hmm.
Should we sing?
Mm-hmm.
No? Okay. The quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. Alyssa just saved y'all's booty because I was about to make you sing. Oh, yes, ma'am. All right, so what I want you to do, take A, B, and C, plug it in. Don't solve. Once you get done, you can put it up. We'll finish tomorrow. Got it?